Hey everyone, and welcome to today's Explainer. We hear it all the time, right? The world is shrinking. We're constantly told we live in this magical era of weightless data and instant global connection. But guess what? The truth is actually deeply, heavily physical. Our seemingly invisible, connected world is actually built on massive, heavy brick and steel infrastructure. So today, we're pulling back the curtain on the real-world machinery that literally makes our modern global economy possible. Let's dive in. So let's start with the ultimate symbol of this whole invisible world, the cloud. We literally all use it, but what is it really? Well, rather than some fluffy white mass floating up in the sky, think of cloud computing as a networked computer-as-utility system. It's actually highly analogous to the 19th century electricity generating industry. Back then, businesses realized it made no sense to run their own individual generators, so they plugged into a brand new shared electric grid. Today, companies are doing the exact same thing with computing power. They're abandoning individual servers to plug into massive, centralized systems provided over the internet by tech giants. There's this brilliant quote that hits the nail right on the head. These are the wheelworks, the cloud is their avatar. When we say cloud computing, we aren't talking about vapor. We are talking about massive, industrial server farms. Picture vast, unmarked brick buildings with smoked windows. We're talking miles of hollow floors, huge diesel generators, colossal cooling towers, and aluminum chimney stacks. This hidden infrastructure consumes absolutely enormous amounts of cheap electricity. The cloud isn't weightless at all, guys. It's a sprawling industrial complex. All right, so if the cloud is actually grounded in all this heavy infrastructure, how did these massive systems connect globally? To really understand this, we have to look at circulation technologies. Basically, humanity has built two distinct systems to overcome the friction of space and time. On one side, we've got transportation systems. That's how tangible things, like physical materials, products, and people, are moved around. On the other side, we have communication systems, which transmit information, ideas, and instructions. Now, for almost all of human history, these were the exact same thing. Information could only travel as fast as a human or a horse could physically carry it. But the invention of electric technology, that broke that link forever. And it turns out there is an incredible circular feedback loop at play here. Innovations in transportation and communication, they don't just happen in a vacuum. A change in technology leads to a massive infrastructure build-out that leads to experimentation by users, which changes how businesses organize themselves, which then transforms entire territories. All of this creates a totally new profit-making environment that sparks the next wave of technological change. It's just a continuous reinforcing engine of global economic transformation. Over time, the result of that feedback loop is just profound. Imagine real distance, the actual time it takes to get from one part of the world to another, acting like a funnel. In the past, moving around the globe was an incredibly slow, difficult process. But as those transportation innovations compound and we move closer to the present day, the friction of distance is dramatically reduced. The globe is literally shrinking. To really wrap our heads around the sheer scale of this shrinkage, think about the timeline. In the 1500s, right up until the 1840s, the absolute best average speed of horse-drawn coaches and sailing ships was barely 10 miles per hour. Then, boom, we get a major breakthrough, steam power. By the 1850s, steam locomotives and ships are averaging 36 to 65 miles per hour. That alone radically transformed global trade. But the true takeoff, that happens in the 1950s with the introduction of commercial jet aircraft, rocketing speeds up to 500 to 600 miles per hour. Suddenly, direct, face-to-face global corporate control became an actual reality. But hey, speed is really only half the story here. The absolutely crucial point is cost. Consider this number, 30 cents. By the year 2000, the price of air freight fell to less than 30 cents per ton kilometer. Why does this matter? Well, because this massive plunge in transportation costs is exactly what makes modern business possible. It fills this essential niche in just-in-time production systems. If a company needs to fine-tune its supply chains or ship lightweight, high-value goods like smartphones or even highly perishable items across continents, super cheap air freight makes it all economically viable. Now, while jets handle the fast, pricey shipments, what about the heavy lifting? That brings us to the great unsung wonder of the modern world. 90%. That is the staggering amount of all non-bulk global cargo that's moved using one surprisingly simple innovation, the shipping container. Launched in the 1950s, containerization completely simplified how we transfer freight between trucks, trains, and ships. It increased security, drastically slashed costs, and fundamentally revolutionized the entire global economic system. Honestly, container shipping easily ranks among the top 10 most influential industries of the past few decades. And just to put the sheer scale of this into perspective, think about the first container ship back in 1956. It was just a converted oil tanker carrying maybe 58 containers. Now compare that to the 2013 Triple E-class ships. These absolute leviathans are over 40 meters wide and can carry a massive 18,000 containers at once. And get this, there's already talk of ships capable of carrying 25,000 containers. The physical volume of goods moving across our oceans right now is almost beyond human comprehension, completely reshaping port cities and global supply chains. So with all these mega ships, jet airplanes, and massive data centers, it really feels like the whole world has been squished down into this highly connected, easily accessible global village. But we've got to ask a pretty critical question here. Is the world shrinking for everyone equally? The answer to that is a definitive no. This idea of time-space convergence, it's actually highly uneven. It's incredibly plastic. Building these massive transportation and communication infrastructures requires colossal investments. And, well, big money goes where financial returns are highest. Because of this, the world's major cities and financial hubs are being rapidly pulled closer together in terms of time and cost. But less developed countries, smaller towns and rural areas, they are effectively being left behind. For them, the world isn't shrinking at all. Relative to those global hubs, their distance is actually stretching out. And this exact same unevenness applies to our communications infrastructure too. Alongside those ships and jets, we've built an invisible information web. It started revolutionizing the globe in the mid-1960s with satellites like Earlybird. Back then, it could carry 240 phone calls or just 2 TV channels, which, by the way, was totally revolutionary at the time. Today, an expansive network of optical fiber cables works right alongside modern satellites, transmitting data globally at light speed. For the major hubs connected to this network, telecommunication essentially pushes the meaning of space entirely towards zero. Which kind of brings us to a somewhat amusing but honestly deeply profound realization. Even if we push the concept of space all the way to zero, we just cannot escape the physical reality of the planet itself. The Earth still rotates, right? It still has simultaneous day and night. No matter how much the globe shrinks through satellites and fiber optics, an inconsiderate global phone call can still absolutely jolt you out of bed in the middle of your night. So it leaves us with this thought. If space really means nothing, what do we lose when we realize we're still bound by the relentless physical realities of the Earth? Thanks for exploring this with us today.